There is a tectonic shift underway in computing. Something so massive, it's reshaping the entire energy industry, computing, and even geopolitics. Let me show you. Last December, it was just quiet farmland. Today, it hosts one of the largest AI data centers on Earth. Close to 1 million AI processors under one roof, pulling up to 2 gigawatts of power. And the most remarkable detail inside there is not a single GPU. This is the first AI supercluster of this scale, built without a single GPU. And this is either the smartest bat in modern AI or the most expensive miscalculation in the history. I have spent more than a decade in semiconductor industry, but nothing prepared me for this. Across the planet, farmland is giving way to data centers. Mother Earth is starting to look like a motherboard. This is rural Indiana, a quiet town called New Carlisle, with population of 1,900 people. Today, it hosts the Project Rainier, an 11 billion AI supercluster. Amazon didn't just stumble into Indiana. This was a calculated choice. Vast, affordable land, space to expand far beyond what exists today, and most importantly, the access to power grid that can deliver more than 2 gigawatts of power. The project was announced last year, and somehow, it's already operational under 12 months. For something that large and that custom, that's a breakneck pace, and the timing is no coincidence. Right now, the largest tech companies on the planet, Google, Meta, Amazon, and others are locked in the race to control AI infrastructure itself. Not just the models, but the physical foundation these models run on. Hundreds of AI clusters are racing across the United States, Europe, and Asia, and almost all of them follow the same formula. Endless rows of GPUs. But Project Rainier breaks that pattern. It already operates 7 buildings, with planned for up to 30 total buildings on that site alone. What makes it fundamentally different is what sits inside. Instead of filling all these rooms with GPUs, Amazon built the system around its own in-house design chips, which are integrated in quite a different infrastructure. And that decision changed everything economically, technically, and strategically. And this is where all the risks begin. Until now, the rules were simple. Buy GPUs, scale, repeat. The more, the better. Okay. And so, anyways, the more you buy, the more you save. In the largest AI superclusters, GPUs are now effectively everywhere. Take the world's biggest AI supercluster today, xAI's Colossus 2 in Memphis. It runs close to 1 million NVIDIA Hopper and Blackwell GPUs under one roof. This model is powerful and proven. It's also scaling in a predictable way, but it is showing cracks. Explosive demand has made GPUs the primary constraint, and it got worse as manufacturing delays started to pile up and actually the bottleneck shifted from chip production to packaging. The interesting part is that Blackwell GPU relies on TSMC's advanced packaging technology, so-called CoWoS-L packaging, chip-on-wafer-on-substrate packaging. This packaging tightly integrates high-bandwidth memory directly with the GPU on one single massive interposer. That single packaging step has quietly become the true choke point of the AI supply chain. Demand for Hopper and Blackwell systems now exceeds what TSMC advanced packaging capacity can physically produce. As someone who spent years in the industry, seeing what happening with Blackwell genuinely scared me. Lead times stretched into months. Costs climbed, and not just for the chips, but for everything around them. Many still think NVIDIA is selling GPUs or graphic cards. In reality, they control the entire AI ecosystem, while actually they sell infrastructure server platform like AGX platform, including networking solutions and enterprise software. This means big tech and AI labs were no longer simply buying compute, but buying into an entire controlled ecosystem. When a single high-end rack can approach $3 million, you can imagine what it means to fill an entire data center with thousands of them. At the same time, workloads kept exploding. Models jumped from billions to tens of trillions of parameters. Training cycles stretched across many months. Power demand climbed into the gigawatt range. Suddenly, the performance alone was not the main constraint. Cost and efficiency became just as critical as the raw compute. And with that, competition just changed its nature. Now, hyperscalers are no longer racing to train the best models, but also to control the silicon these models run on. And this is the pivotal moment where the whole trajectory is shifted. Amazon saw it early. Even at their scale, they did not have the control of its own AI infrastructure. It had to be owned, controlled, and optimized from the inside. So the strategy had to change. Amazon decided to build its own silicon called Trainium. It is so-called ASIC, Application-Specific Integrated Circuit. It's built for month-long process of training large language models. Trainium circuits are designed for this intense process, where large language models are created, refined, and scaled over many months. And you can actually see this on silicon. It's the beauty of ASICs, actually, because you can take the core defining algorithm and literally engrave it in silicon, and that unlocks the efficiency which software algorithms can merely imitate. Inside Trainium 2, you do not find countless small GPU-style cores. You'll find large number of neuron core wrapped in high-bandwidth memory. At a high level, it mirrors the philosophy behind Google TPU. 2 compute dice, 4 stacks of high-bandwidth memory, and advanced CoWoS-R packaging. All of that optimized for cost efficiency and a smooth supply chain. Inside data centers, these chips scale like a root system. Trainium units sit in trays, traceform servers. Racks connects through Amazon's custom network fabric until thousands of AI processors behave like one colossal machine spanning entire buildings. According to Amazon, this setup delivers roughly 50% better pricing than comparable GPU-based systems. And that's a big deal. Plus, this custom solution can reduce data center energy consumption by up to 40%. And that is the whole point, not to outmuscle GPUs on the raw performance. This is still very distant. The objective is more strategic, to control the infrastructure, to tame the cost curve, and dictate the economics. At Amazon reInvent event a couple of days ago, they announced the new Trainium 3 chip, built in 3nm process. And this is where the story pivots, because this project isn't limited by money or silicon. The first battle isn't compute. At this scale, it's power. When you build an AI data center, you are not just stacking servers. You are orchestrating power lines, substations, on-site generation, cooling loops, transformers, and grid stability. When fully built, this site is expected to draw more than 2 gigawatts of power. In a town of just 1,900 people, one AI campus now rivals the power appetite of an entire region with millions of homes. And the local grid was never designed for a machine of this magnitude. The problem was not even the scale, but stability. Massive load pushing the grid to its limits, hovering very close to blackout. Here, finding energy is just a half of the story. Real challenge is keeping it perfectly steady. ... And that's a fundamental difference, because traditional data centers were built around storage and routine compute, while AI data centers are a different beast. They require extreme performance, extreme compute density. GPUs don't draw power smoothly. They demand jumps up and down in milliseconds. If the supply cannot keep up with the swings, the entire system becomes unstable, and a sudden surge can drop voltage and in the worst case, ripples through entire holes, and restarting those runs burns millions of dollars in wasted compute. Here, Amazon had to reinvent how the power flows in a data center. In fact, it doesn't flow directly from the power grid to the racks. It passes through a special stabilization system that smooths out every shock before it reaches the hardware. At Rainier, Amazon deployed a large-scale battery system to absorb power fluctuations. They store energy when demand is low and release it instantly when demand surges. The result is calm, predictable power, feeding hundreds of thousands of AI chips without interruption. And this is where the shift becomes obvious. Hyperscalers are no longer just building data centers. They're literally turning into energy developers. Just like Amazon along AI campuses, they are funding power plants, reinforcing grids, and investing in renewables. And all of it to lock in cheap, reliable electricity before anyone else gets there first. And at the same time, they're pursuing the second level of control, designing custom silicon to squeeze as much compute as possible from every watt of power. And this actually defines the next stage of AI development, because the race is no longer about performance. It's about who can engineer a whole system where power, cooling, silicon, and data moves in a perfect lockstep and keep working as scale moves from colossal to absurd. And if you're enjoying this episode and you care about where the whole computing is heading, subscribe to the channel. And this race at the infrastructure level is reshaping another one just as critical: skills. We are coming at the end of the year, and AI was one of the most in-demand skills as of 2025, according to the World Economic Forum. And as 2026 approaches, the demand is only accelerating. Yet many people still have not learned it. That's why I recommend you join me for the 2-day AI workshop by Outskill. They're hosting a live workshop this Saturday and Sunday from 10 a.m. to 7 p.m. EST on both days. More than 10 million professionals, just like you, have already attended this training. From marketers to engineers to founders. And many walked away, not just smarter, but with skills they can monetize. And the timing is perfect because right now they have a special holiday offer. And you can attend this training, which usually costs $395 for free. I highly recommend you to join this training because you will be mentored by AI experts from companies like Microsoft and NVIDIA. Inside this 16 hours, you will learn how to use AI to simplify your daily work, build AI agents, automate your workflows across Sheets, Notion, and CRMs, create real-time AI systems you can use for your job, business, or project. You will also receive bonuses worth over $5,000 if you attend both days, including a prompt Bible, a personalized AI toolkit, and a roadmap to monetize these skills. This is your opportunity to step into 2026 sharper, more skilled, and ready to level up your career. Register right now through the link below or scan the QR code here and join their WhatsApp community to stay updated before the training starts. And thank you, Outskill, for sponsoring this episode. Well, securing 2 gigawatts of power only unlocks the next problem. The moment electricity hits the servers, it becomes heat, and the scale is unforgiving. It's roughly 2 gigawatts of heat wrapped inside 4 walls. Now, how do you remove all of that heat? To cool a data center at this scale, it takes millions of gallons of water every day. And subscribe the channel, AI Unlocked.